Hi everyone. I want us to imagine a story. So you are a woman whose son has went off to war, has off to fight in Europe, and you're living in Massachusetts. So he comes back and he is pretty sick, has like a version of the flu. You help him get well. Some of his battalion mates die pretty quickly, and you think, there's something really strong about the flu this year. And you write up to your sister, and she's like, and she lives up here in New Hampshire, and says, wow, there's some people sick here too. And you're like, guess it's just that time of year. And then the newspaper starts to say that people all the way over here in California are also sick. And you're like, this is starting to seem a little weird. And then the next week, by the middle of the week, beginning of October, the newspapers are saying it's all over the country. People are dying all over the country from this mysterious version of the flu, and eventually it reaches a pandemic in the US and all over the world. So the influenza of 1918 ended up killing about 750,000 people in the US, and even more worldwide. So this is not only the kind of thing of horror movies, this is the kind of thing that really does happen. And so we're going to talk today about infectious diseases. This is just a walking through of the whole map, and how quickly that spreads. Less than a month all over the country, from just a couple people. So today we're talking about infectious diseases and vaccination. So what happens when the immune system doesn't work like it's supposed to, or it does and a disease keeps spreading anyway, and vaccination, the main way we can attempt to prevent this kind of disease from spreading. So when your immune system doesn't fight off an infection immediately, you get sick. So you might have a rash or a fever or stomach pains, gastrointestinal problems. You might cough. This doesn't mean that your immune system has failed. It's just working on fighting off that invader. So if it's the kind of sickness that you eventually get better from, like almost all sickness, then it is just a normal illness. Your immune system is dealing with the problem. However, if your immune system fails completely, so say something is wrong with your macrophages or neutrophils or T cells, any of the pieces that we talked about last week, then you were what's considered immunocompromised. So let's break down this word. Immuno, like immune, and compromised, as in there's something wrong with it. There's something that's not as good as it should be. And then you have an opportunistic, like opportunity, infection. So this is a much worse version of a rash or a fever, or stomach pain or a cough. So for instance, say somebody is being treated for cancer, so they have chemotherapy, they're undergoing chemotherapy. So the chemotherapy is attacking all of their immune cells, not just the cancer. Then they may have a weakened immune system, that is that they're immunocompromised and they are at risk for opportunistic infection. This also applies to diseases like HIV that specifically target the immune system. So why haven't our immune systems become really strong over time? Why does our immune system not just attack everything that comes into it that might be an antigen? So there's two kind of problems with this. If our immune systems were super strong and they just attacked everything, then they would attack two categories of things that they shouldn't attack. First, like happens in allergies, it would attack outside antigens that should be safe. So say milk, dust, certain types of nuts or sesame, things that should be safe for us to eat. Your immune system decides it's not. It produces antibodies in relation to that, and you have all of the reactions that you might have when something is actually dangerous. So you might cough, you might swell up, and these can be fatal as well. So we don't want our immune system to be too strong, because then it may attack things that should be safe. The other reason we don't want our immune system to be too strong is because it will begin to identify the body itself as something that is a foreign invader that should not be there. So these are called autoimmune disorders. So the immune system attacks a different kind of body cell. So in type 1 diabetes, the immune system attacks the pancreas. We're going to talk about this more in a few weeks. But it attacks the beta cells of the pancreas. And because of that, it can't make insulin and you cannot digest sugar. Inflammatory bowel disease, similar thing. Your immune system attacks your gastrointestinal tract. Arthritis and multiple sclerosis, it attacks your ligaments and your joints. So this is also a massive problem when the body attacks itself because it thinks that it's a foreign invader. So can think of two different reasons that the immune system shouldn't just attack everything, because one, it can attack things that are safe in the case of allergies, and two, it can attack itself in the case of autoimmune disorders. So infectious disease is one type of disease, but let's think about all the different types of diseases that we're going to talk about this semester. So again, infectious is the first type. It passes between people. Physiological is pertaining to a particular disease system, and when it breaks down, maybe because of age, maybe because of injury. A genetic disease is something that's passed between generations. It's passed from your parents, and microdeficiency happens when there is a vitamin or mineral that you should be getting a lot of in order to make your body systems function the way that they're supposed to, and you don't get enough of it. So little, and deficiency, not getting enough of something. So there are two different categories of diseases. First, we're going to talk about communicable diseases, that is, diseases that can be passed from one person to another, versus non-communicable diseases, that is, that they cannot be passed from one person to another. I want to go back quickly and reiterate that these are not mutually exclusive. So a disease doesn't just have to be one. So for instance, we think that diabetes has a genetic component sometimes, but it's also physiological because it's the breakdown of a system. And so infectious disease is the only one that is communicable. It's the only one that can pass between people. You can catch it from somewhere else. And the other three, physiological, genetic, and microdeficiency, are what are known as non-communicable diseases. So again, we're starting with infectious disease today. So how do infectious and communicable diseases actually spread? There are two main methods of the spread of these kinds of diseases. There's direct contact. So let's say that you're holding your small sibling and they sneeze right in your face, they cough right in your face. If they have a cold, then you too will now be exposed to that cold virus. So you may get sick. You may not get sick. Your immune system might fight it off before you actually see the symptoms. And so this is an example of droplet spread. So the droplets containing the cold virus have now caught into your face. An example of person-to-person contact, say someone was to, for instance, kiss someone who had a cold. Since this is a direct sharing of fluids, it's directly between two people, this would be considered person-to-person contact. But since these are both directly between two people are interfacing, this is considered direct contact in terms of how diseases are spread. The other kind, maybe intuitively, is called indirect contact, so not direct contact. So there are a few more of these. There can be airborne transmission. That is a disease that can live in the air for a long period of time. These are really terrifying. I feel like these are the ones that a lot of, for instance, epidemic movies are about. Because if something can live in the air, then it can very quickly spread. But there, thank goodness, aren't very many examples of airborne transmissions in our world. There are contaminated objects. So this is, for instance, why you wouldn't use a needle on one patient and then go use a needle on another patient, because that material that you're drawing from that patient, be it blood or plasma, or something from a biopsy, could all have parts of disease in them, and you wouldn't want to spread it to the next person. There's also animal-to-person diseases, so called zoonotic diseases. So, for instance, if a dog or a bat or another kind of animal had rabies, if they were to bite someone, then it would be passing from an animal to a person. This is also, for instance, mad cow disease in the UK in the 90s, also passed from animals to people. There's also food diseases and drinking water diseases. So something like not cooking meat correctly could give you a disease. So, for instance, listeria or E. coli can be from not correctly washing vegetables, or botulism from not correctly cooking meat. There's also insect bites. So these are called vector-borne diseases. So a classic example, which we're going to talk about more in a minute, is called malaria, which is endemic to Central Africa. And so mosquitoes take the blood of one person, they drink it, they are a carrier of malaria, then they bite another person, part of that person's blood gets into the next person, and they also contract malaria. Also, environmental reservoirs. So, say a bunch of people are all drawing water from the same source. That source is then contaminated with fecal matter. And because of that, it is going to infect everybody who also draws from that source. So even if you're washing clothes, even if you're not drinking it. So a classic example of this is cholera. So two main types of ways: direct contact and indirect contact, and to know a couple of examples of each. So now we're going to get to the fun etymological portion of our lecture today. So we're talking about endemic versus epidemic versus pandemic. So starting off with the combining form, we have demos, or people. It's a Greek combining form, and it is in words like demographic, so when you count people and categorize them, or democracy, so a governmental system that is supposed to be of the people. And then we have three prefixes that we can combine these two. So we have en, epi, and pan. En meaning to place in or to confine. So endemic is internal to a population. It's permanent to that population. So it's in people. Epidemic is upon people. So it's something that starts quickly and spreads within a population. For instance, it would be called an outbreak. It's a particular disease chain of events. And a pandemic, so everything or all, so it affects all people. So it's a worldwide spread of disease. So we're going to talk about these in a little bit more detail in the second part of this lecture.